Hi, everyone. Thank you for joining ICEHOUSE Public GeekTalk. Um, what I'm going to present today is a familiar topic for developers revolving around code reviews. Being a developer myself and having exposed to code reviews, I feel that there's a lot of benefits when we do code reviews. So to the project and anyone that's involved in the process. So we're going to discuss the motivations behind code reviews and how to do code review effectively so that we can build better apps and teams. Okay, so here we go. Right, the following is the outline of this presentation. In the first section, we're going to talk about the motivation or reasons behind doing code reviews. Why should we do it? Next, we're going to deep dive on how to practice code review. As the submitting author and the reviewer, there are three topics that we're going to discuss further here. First, preparing code for review as an author or submitter. There are a few points that may help you a smoother and quicker review process. Second, getting through a code review. We're going to discuss mostly here on what to look out for during a code review as a reviewer and how to respond as the author. And third, we're going to spend some time on why doing small changes is always better rather than doing large ones. We're also going to see the result of a case study at Cisco Systems that supports this. In the third section, we're going to go through briefly on a code review case study done at Google. And last, we're going to close with key takeaways. All right, so the first reason why we should do code review is for better code quality. Well, when we're development, it serves as important checkpoints for the team to maintain quality of the code changes before it is submitted to the code base. This is because the primary purpose of code review is to make sure that the overall code health of the code base is not decreasing in quality, but rather it should improve over time. During these checkpoints, the following are possible to do to help maintain code quality. First, requirement implementation verification. This is verifying that the changes meet requirements of the feature, including compliance to non-functional requirements like security and performance requirement, and whether it follows agreed to software architecture pattern, if any. Other than that, the implementation should be also checked whether it is within requirement scope boundaries and also testable, whether manual or using automated checks. Next, maintaining readability and consistency throughout the code base. This includes compliance with coding conventions and other specific company style guidelines. And last, with the same importance as any others, is defect and backfinding. Other than bugs, such defects we are talking about are concurrency, deadlock, race condition issues. These kinds of issues are more difficult to identify at later stages of development. And so it is better to find it as early and often as possible. Well, according to NIST, National Institute of Standards and Technology, the cost of detecting and fixing defects in application increases exponentially when found so much later in development stages. The costs that we're talking about here are not just in the form of time and resource wasted, but also in the form of lost opportunities. In the future, such opportunities are lost, for example, because of the bugs that were found later in production stages and causing reputation damage and business loss. Let's take a look at the graph to understand why the cost increased exponentially. To make it simpler, we're breaking down development stages here into three: coding stage displayed in green bars, testing stage in yellow, and production stage in red. At the coding stage here, the developers are still writing the code, so it's much easier for them to detect issues and fix them immediately since the code is still fresh in mind. However, once the software is in the testing stage, finding and reproducing the defects might be more challenging. While it's very easy to catch something broken or not according to the requirements, but it is difficult to uncover defects which are more fundamental, such as memory leaks or concurrency issues. And when the application is in production stage or released, it's not just difficult to find defects, but it's also incredibly risky as well. Um, while we want to prevent live users affected by the problems, ensuring availability of the service is also business critical. So for these reasons, it is better to find defects as early and often as possible. To emphasize the importance of finding defects as early as possible, let's take a look at the following real-world case study. So this company tracked how many bugs are found in a 3-month project where there are 10 developers involved in it. They also measured the total cost for fixing those bugs, which some were found by the QA and others were found by the customer on the production stage. The total costs were around 368K US dollars. Then to test exactly how much money the company would have saved, they had another group developers to do code review on the same code, the one after development here. It turned out that more than the half of the bugs were found during code reviews, and they would have saved more than half the cost of fixing the bugs that way. The company would have saved around 200K US dollar if they used code review for the first time. Well, for the second reason that we should do code review is to encourage team members to work and learn together, which will also strengthen the bonds between them. When a team does code reviews regularly, it will promote an atmosphere where the entire team is responsible for improving code health of the code base. So each member will have an increased sense of mutual responsibility. Code reviews also help spreading or facilitate knowledge sharing between team members. It provides sharing and learning opportunities between senior and junior developers, including introducing better techniques or approaches to solve a problem. It also helps team members to get familiar with the code base, especially for those joining the team in later stages of development. Right. And now let's dive into code review in practice. Well, first we're going to talk about how to prepare a code for a review. Preparing for a code review is also important since we want to get through it as smoothly and as quickly as possible. First, we have to understand and clarify requirements before implementation. Avoid any additional code changes or implementation that is not needed now or even in the future. Next, we need to try to submit code changes in small chunks and as often as possible, because small code changes allow for many advantages that we will discuss later. Then every code change submission should have a unit test along with it. Make sure it has good coverage test cases such as positive, negative, and possible edge cases. Double check by performing your code review on your own code. Run all available unit tests before submitting one last time when necessary. And also, we need to write brief and clear commit messages, including pull request descriptions, to help reviewers quickly understand your code without headaches. This is also important for better log and tracking history. Okay, so let's take a look here at the following Git message example. This is a good example how the commit message should be structured. For the first line here, write the capitalized brief and clear message summary. What is being done in an imperative sentence with a maximum of 50 characters or less. And this is important. It should be followed by an empty line should you decide to include a more detailed description below. For the rest of the body, Write a more detailed but brief enough description of what's being done in the commit. Also provide enough information on what's being done. One-liner messages such as fix bug A does not provide enough user information and it's too short for future readers. So it's better instead if you write why the bug exists and how did you fix it. I think that was it on the preparing code review. So we are going to discuss now on how to get through a code review. As a general guideline, remember the following. Prioritize code review whenever there are no immediate tasks at hand, since it may block other developers working on a new feature based on the changes. Take an approximate amount of time to review because according to study done at Cisco Systems, reviewers become less effective when doing a faster um, code review with a pace more than 500 lines of code per hour. And more importantly, be constructive because we want to build a positive code review culture within the team. You need to highlight, compliment, and good practices. Try to find things on code review that you like. For example, oh, I like what you did here. It's very straightforward and so on. And in general, when we do code reviews, actually, we aren't exactly encouraged to do that because we naturally think our job is to find problems. Right? But we should forget that the code review process is also a place to help people to learn. And if someone has done something well, we need to encourage them so that they will remember that it is a good thing and they will continue carry on that by that's part of the learning process. We learn by being praised as well as being told that is wrong. So there's a balance there. And sorry. And we should remember the comment should be specific about the author. Sorry, should be specific and only relates to the code, not to the author. Now, we're going to go through on what to look out for in a code review as a reviewer. First, check its purpose and design. One of the most important aspects of code review is to make sure that the changes should meet all requirements and are designed thoughtfully. Some questions that we may ask during a code review, do the changes meet all requirements of the feature? This means checking whether functional requirements are fulfilled and compliance to non-functional requirements like security and performance requirements are followed. It should be remembered as well that all changes should be made for a reason. This is to avoid over-engineering. Next, do the structure of the code changes make sense? The code shouldn't be too complex, can be understood quickly by the reader, and easy to be modified and thus not prone to errors when modified by future developers. Are there any pieces of the code that should have belonged elsewhere? For example, does it belong on the correct class, or maybe it should have belonged in a library? Well, another question to ask is, are there new dependencies introduced? We should check if there is any known defects or security issues in the library. And perhaps we need to refine dependency configuration if necessary. For example, disabling features we don't need, or change default configuration values. And also don't forget to check library's usage license, where it's fine to include it in your project. All right, so next we have to check its implementation and functionality. Take time to review every function implementation in detail, run automated and functional tests to make sure it is working correctly. Here's some more questions to ask yourself during the review. Are all input validated? This is important if you want the code to be as defensive as possible. Are there any code smells? For example, whether there are any code duplications or any cyclomatic complexity. It's also better to do this automatically with a static code analyzer like SonarQube and have it integrated with code review process flow. Okay. So you should check also if there is any unit UI or end-to-end test. It's important that each code change submissions are testable and have automated tests related to it. Those tests should be correct, sensible, useful, and sufficient test coverage is ensured, like positive, negative, and edge cases. And lastly, we need to check for its readability and consistency. Um, Make sure that the code is easy to understand and matches the current style of the code base. Some more questions to ask yourself during the review. Are there any code conventions or specific company style guidelines that should be followed? Does everything have clear and sensible names? A sensible name is long enough to fully communicate what the item is or does, but without being so long, it becomes hard to read. Is the coding style consistent with the code base? Are existing documentation already updated to match the current changes? For example, we have to ensure that API documentations, database schema, designs, and architecture diagrams are up to date. And lastly, are there sufficient code comments and documentations? Sometimes explaining why some piece of code is required, if not self-explanatory. Okay, so I guess that's all on what to look out for during code review. And now we're going to see why it's always a better idea to have small changes and frequent rather than having large ones when submitting for a code review. As I've mentioned before, reading other people's code is hard, especially large code changes. Large code changes tend to overwhelm the reviewer, and reviewing becomes less efficient since a person can only process so much information at once. As a result, um, large code changes may cause decrease in defect finding, taking too much time to review and more stressful experience to the reviewers. But when we're doing it in small changes, it has the following benefits instead. It will have detailed and quick reviews. Reviewers will find it easier to find time to do the review and will be more likely to have detailed inspection. Now, it will also less likely to introduce defects. With fewer changes, it's easier for the reader to think about the impact of code changes, identifying concerns and finding any defects that may occur. And also it will be easier and faster to merge. Smaller code changes means taking less time to work on it and less likely to cause conflicts when submitting to the code base. Right. So let's take a look at the following graph. This graph from a code review study done at Cisco Systems shows the relationship between defect density and the amount of code or lines of code under review. Defect density here means that the number of defects found per 1,000 lines of code. As you can see here, marked by the red rectangle, any review below 200 lines produces a relatively high rate of defects, but no review larger than 250 lines produce more than 37 defects per 1,000 lines of code. And this makes sense, right? Because if the reviewer is overwhelmed with a large quantity of code, he won't give the same attention to every line as he might with a small change. He won't be able to explore all the impacts of the change in a single time effectively. But then again, this also depends on how fast the reviewer inspects the code at a time. The review shouldn't be too fast, affecting the reviewer's ability to find defects. So let's take a look at another graph. This also taken from Cisco System Code Review Study, where we can see the relationship between defect density and reviewers' inspection rate or lines of code per hour. As you can see here, marked by the red rectangle, reviewers slower, doing the review slower than 400 lines per hour were above average in their ability to uncover defects. But when faster than 450 lines per hour, the reviewer's performance at finding defects starts to drop, and the number of defects found is below average in almost 90% of the reviews. From these results, it makes sense that the reviewers who are too fast going through a review um, won't find many defects as they should. When a review is too fast, it might mean that the reviewer didn't take enough time for it, or it could mean that the reviewer couldn't give enough time for a review with large code changes. So that is another reason why it is better to submit smaller code changes and frequently rather than having large ones. There is another interesting find from Cisco Systems Code Review study that begins with the following question. Um, can we reduce the number of defects even before the review begins? The simple idea is to have the developers double check their work so that the reviews could be completed faster without compromising code quality. So they conduct a test where they have two groups of developers to submit code changes differently on each group. The first group of developers submit their code changes as usual, and the second group are required to submit their code with annotations or comments prepared throughout their changes during the review. Well, the comments are placed there by the developer or the author to guide the reviewer through the changes. For example, showing which files to look at first, and if there are any concerns to look out for, and explaining the reason behind such modifications. The results are shown on this graph. It turns out that the second group, which have the blank dot here with preparation, produces slower defects than the first group. One conclusion is that the action of preparing comments by the author before the review causes the author itself to identify any correct most defects on his own, and thus making the review itself more efficient. So when you can't avoid large changes, um, I recommend that authors should prepare initial comments to the code changes during the review. Well, first, it will serve as a guide for reviewers for better and quick understanding of the changes. And secondly, such preparation will cause anyone to be more careful, rethink their logic, and write better code overall. All right. Um, now we're going to go through on how to respond to comments as the author. As I've mentioned before, understanding other people's code is hard and can be frustrating, which can cause a varied comment from reviewers. And when responding to those comments, always have in mind um, the goal of the review itself is to maintain the quality of the code base and deliver the highest quality app, which requires effort from all members of the team. So be nice and be patient. No matter how confident you are with your own changes, always consider if the reviewer is providing you with feedback that helps improve the quality of the changes even further. And when the reviewer does not understand the code immediately, there's a chance that future readers will also neither. So try to add brief but um, meaningful comments to your code, or consider refactoring to clarify your code if adding comments doesn't help. So I guess that's all for code review in practice. And now we're going to heading to another section. Um, we're going to go through on a case study at Google. So code review has been an important and required part of software development and process in Google since the company's early beginnings. It has become a core part of Google culture. The code review process itself and tooling itself have been improved over and over for more than a decade, and is applied by thousands of developers making thousands of source code changes each day from offices around the world. And here we're going to discuss the result of the case study based on a paper titled Modern Code Review, a case study at Google, which will cover these these three topics. First, early motivations and current expectations. Then we're going to see how they practice code review at Google. And also, how do Google developers perceive code review? What do they think? Okay. And so let's dive in. So we're going to talk about how it started and its early motivations first. It was introduced early on by one of the first employees, so I'm not sure when they started doing code review, but it's been more than a decade, obviously, right now. The main answer written that they're doing code review in the first place is to force developers to write code that other developers could understand. It's simple. Of course, it's good if reviewers find bugs, but this is not the main focus. The foremost reason for doing code reviews is to improve code understandability and maintainability. It was important because the code is written once and read many times. Then the code must act as a teacher for future developers. Code review was also seen as capable of making sure that more than one developer is familiar with every part of the code base, and thus increasing the chances of knowledge staying within the company. And soon enough, there are other benefits that become clear and transformed into expectations when doing code reviews at Google. These are the current expectations. Well, first, this is kind of obvious. It was education. Education here refers to teaching or learning from a code review. It is broadly valued at Google and mostly depends on the work relationship between the author and reviewers. Next is maintaining the norms. It refers to maintaining organization's preference or discriminatory choice, such as code formatting style or API usage patterns. And also gatekeeping. Gatekeeping here concerns on the establishment and maintenance of boundaries around the source code, design choices, or other artifacts. And also accident prevention. Accident prevention here refers to the prevention of bugs, defects, or other quality-related issues. In a way, the code review process improves security as well by making sure that no single developer can commit arbitrary code without oversight. And then tracking history. This is important as well. It refers to tracking history of code changes and capturing developer interactions with the code review tool. And it turns out that developers at Google also use the code review history to understand how bugs were introduced to make sure it doesn't happen again. Right. So here is the author and reviewer context relationship diagram with expectations mentioned earlier. These expectations came up depending on the relationship between the author and the reviewer. For example, expectations on maintaining the norms came up between developer or the author and those with a different seniority. For example, a project lead or expert readability reviewers and new team members. But not the same case with other fields where instead gatekeeping and accident prevention are primary. As a project leader with expectation of education and maintaining the norms, he or she will verify that the changes that have been submitted by the developer have met Google guidelines, while others which came from another team, pardon me, another team such as deployment or maintenance team, will verify that the changes have met the deployment or maintenance requirements or within their deployment boundaries. As for the new team members here, although have the same expectation as project leader, but are in different contexts, here the new team members are expected to learn and get familiar with the project with the help of the author and other experienced team members. So How does the code review process at Google look like, and what kind of tools do they use? So first thing first, the study was done in 2018, so it may have been updated or refined up to this point, but we'll discuss what we know based on the study. As we can see on the diagram, the code review process flow looks generally the same as when we were working on a project with GitHub or Bitbucket, where we ask other developers to review your code changes before submitting to the repository. So on this slide, I will highlight more on the requirements and tools placed around the code reviews on Google. For code review, Google has internally developed web-based tool called Critique, integrated with a static code analysis tool called Tricorder here. The tricorder will do automated simple style checks, compiler-based analysis, and project-specific checks, and display the result as comments along with others from the reviewer. Deployment at Google also required to include pre-commit checks, like basic automatic style checks and running automated test suites. It's triggered when code changes are being submitted to the repository. And the result of pre-commit checks are also visible in the critique. So in terms of review frequency and speed at Google, code review process has the following statistics. Well, the median for code changes being submitted for review is about 3 per week, and about 80% of the author makes fewer than 7 changes. And similarly, the median for changes reviewed by developers per week is 4, and 80% of the reviewers review fewer than 10 changes per week. The duration for waiting for initial feedback is about 5 hours for very large changes and under 1 hour for small changes. But mostly the entire review process is usually just under 4 hours, which is pretty quick, um, considering the how company the large the company is. And so what about the size of the review itself? Well, in terms of review size, it's mostly happen in small chunks. Over 35% of code submitted by review modifies only a single file, and about 90% modify fewer than 10 files. And over 10% changes modify single line, with median of lines modified is 24. So a maximum for a code review, perhaps 240 lines. That's a maximum. And in terms of number of reviewers, um, it turns out it has fewer than 25% have more than one reviewer. And over 99% have at most 5 reviewers, but with the median of 1. So mostly one reviewer is often enough. But larger changes usually will have more reviewers on average. Well, the code review process itself at Google is not without challenges. There are 5 themes or challenges based on interview data on the study. First is distance. Distance here is perceived as causing delays in the review process or leading to misunderstanding. Um, it refers to physical distance or geographical, since Google has lots of developers working on different offices around the world, and also organizational distance, for example, between different teams or different roles. Also, social interactions, or specifically communication within code review, which possibly leading to problems from 2 aspects, tone and power. Tone refers to the fact that sometimes authors are sensitive to comments. Um, Sentiment analysis on the comments has provided evidence that comments with negative tone are less likely to be useful. And power refers to using the code review to influence another person to change their behavior by dragging out reviews or withholding approvals. Such cases can make developers uncomfortable or frustrated. And next is review subjects. This one refers to disagreements whether the code review is actually suitable for reviewing certain aspects, such as design review. And then context. This one refers to misunderstandings based on not knowing what gave rise to the change. For example, is it an urgent fix or is it nice to have? And lastly is customization. This one refers to the review tool customization itself, since some teams have different requirements for code review. But despite the challenges, it is still broadly seen as being valuable and efficient within Goodwill, and 97% of developers are satisfied with it based on a survey. Least satisfied replies were associated with changes are being too small, comments are not being too helpful, and the changes under review were only small configuration changes for which code review had less impact. And interestingly, most developers spend around 3 hours a week reviewing, so it doesn't take too much of their time. Yep. All right, so we reached the end of presentation. So here are the key takeaways. Well, code reviews are essential, obviously, for better code quality, which also means better apps in the end. Code reviews also encourages teamwork and learning. And here's a summary of recommended code review practice. There are 3 things to look out for during code review. First, check its purpose and design. Make sure that the changes meet requirements first and are designed thoughtfully. Next, check its implementation and functionality. Take time to review every function implementation in detail. And then its readability and consistency. Make sure that the code is easy to understand and matches the current style of the code base. Always better to submit code changes in small chunks and as often as possible. It has many advantages, as explained before. And provide clear and brief description as well as initial comments as guideline for your reviewers during pull review requests, for example. This is always a good practice for a quicker review in spite of the size of the code change itself. Always take appropriate time to review. As a baseline, around 400 lines of code per hour. And lastly, and importantly, always be constructive. Highlight good practice as well, because we want to build a positive code review culture within the team. Okay, I guess that's the end of my presentation. Thank you for paying attention.